In this problem, we're asked to find the amplitude, the period, the phase shift, and sketch a graph of the function of y equal to 3 sine of x plus 6 over a one-cycle interval. In order to find this, we will recognize that we are in the general form of y equal to a sine of bx plus c. In this case, we will recognize that a is equal to 3, b is equal to 1, and c is equal to a pi over 6. We can use this information to find the amplitude, the period, and the phase shift. First of all, we will recognize that the amplitude, or the maximum output of our function, is always given by the absolute value of a, in this case the absolute value of 3, which is 3. This makes sense because it's going to take all y values that come out of the sine function from -1 to 1 and multiply it by a factor of 3, giving us an overall range of -3 to a positive 3. We will now look at the period. We can recognize the period as by taking the interval 2 pi and dividing it by the absolute value of b. In our case, b is 1. Therefore, we do not change the period. The period stays between 2 pi. We can see that by looking at the inside parentheses and noticing that we only have a phase shift and not a period change. We can now look at that phase shift. Again, by looking at the inside parentheses, we will know that our graph got moved to the left by pi over 6 units. We will also know that our phase shift is given by the formula, the opposite of c over b. In our case, it's the opposite of pi over 6 divided by 1. This tells us that our function did indeed get moved to the left pi over 6. Now we want to find our cycle interval, guaranteeing that it starts at negative pi over 6. We solve the following. X plus pi over 6 falls between 2 pi and 0, subtracting pi over 6 from both sides. 2 pi is equivalent to 12 pi over 6 minus an additional pi over 6 gives us 11 pi over 6, which is our 2 pi interval. We are now ready to use this information to sketch the graph. In order to sketch the graph, I have written the axes from negative pi over 6 to 11 pi over 6. We need to find those 5 critical values of sine. We know at the endpoints, negative pi over 6 and 11 pi over 6, sine should equal to 0. We can verify this by plugging in negative pi over 6, and we get 3 times the sine of 0, which takes us back to 0. Therefore, we have the 2 endpoints at negative pi over 6 and 11 pi over 6. We also know that sine will equal to 0 halfway between this interval. By finding those 5 critical points, we are really dividing the graph into 4 equal parts. If I divide my interval into half, I would end up at pi over 6. Again, this means that my function for sine takes on another 0 at 5 pi over 6. Finally, we need to find the minimum and the maximum value. We can do this a couple ways. We can divide this interval in half, likewise dividing 5 pi over 6 and 11 pi over 6 in half. If we do this, we will end up at add pi over 6, subtract pi over 6. We will end up at 2 pi over 6, which is equivalent to pi over 3. That is our maximum value at a positive 3. Likewise, our minimum value at negative 3 would be halfway between 5 pi over 6 and 11 pi over 6. Going over 3 in each case, I would be at 9 pi over 6, which is equivalent to divide both sides by 3. I would be at not 9 pi over 6, but 8 pi over 6, which is 4 pi over 3. That would give my minimum value at negative 3. I am now ready to sketch my graph of my function. We will notice that from the x-intercept to the maximum, I have an interval of pi over 2 units.